nothing insane that we're going to talk about today. 7.2, properties of parallelograms. So, does anyone know from 6th grade what a parallelogram is? Remember? Really? It is a shape. Wait, who said they know what it is? Really? Can you draw one?
Yeah, I can draw it.
Okay. Shh, I'm giving hints. Okay.
When these are parallel, I'm not do the parallel thing. Like, show it a parallel.
Parallel is a little triangle.
Oh yeah,
This is riveting.
What else is parallel?
They're not all parallel to each other. Just one across each other.
I don't know why this is difficult for me to say, but Alton's right on. So, yes, a parallelogram is a shape, not maybe exactly like what we see in the picture he drew, but he's got the right ideas. Somebody said a rhombus. Wow, that's even worse. Somebody said a rhombus. A rhombus would be an example. That looks like that thing in Star Wars 4. But two sets of parallel lines, right? Like Alton said, this side and this side are parallel. Also, the top and bottom are parallel. So we'll look into that a little bit more. But we're going to look at some properties of a parallelogram and how we can find some different things with those properties. Am I recording? I think so. Sweet. Review, terms, example, practice. So, a parallelogram. Here's the technical definition. If you want to write this down, go for it. Also, if you just want to quote Alton, that would work. A parallelogram is a quadrilateral. So quadrilateral, that's 4 sides, right? With both pairs of opposite sides being parallel. In quadrilateral, PQRS, PQ is parallel to RS, and QR is parallel to PS by definition. The theorems that we're going to look at to talk about other properties, like things with angles, things with sides, and kind of what that means for the angles and sides, with the top and bottom being parallel and the 2 sides being parallel. This definition, like a lot of the other definitions we've looked at, I think is one that, again, you don't have to write down, but if you do, I think that picture would be a very good explanation if you don't want to write all those words down. I needed to forget how to read over I was worried for a second, but you reassured me, so thank you. Okay, next one. So here's a theorem for us. Kind of since we have, or when we have parallelograms, then we're going to look at, all of our theorems are going to start with if PQRS is a parallelogram, then something else is true. So all of these are going to have to do with if we have parallelograms, then we can draw these conclusions. So if we have a parallelogram, then the opposite sides are congruent. All right. So if we have a parallelogram, then QR is congruent to PS and QP is congruent to RS. Those opposite sides are congruent, which hopefully doesn't surprise us. Again, for this, we're going to list off, I think, 3 or 4 theorems, and drawing a picture for this one would be plenty. If you see a picture with those, or if you see the name, parallel opposite sides theorem, that kind of tells you what's going on. So those sides are parallel, they also are congruent. If those sides are parallel and congruent, what do we think that means about the opposite angles? Yes, whoever said congruent, somebody whispered it. If we have a parallelogram, then not only are the opposite sides congruent, but the opposite angles are also congruent. This, again, should not be too big of a surprise. For this one, I think drawing a picture again would be better. Questions on those first two theorems? Okay. So that leads us to a question like this. Find the values of x and y. Well, if we start with finding x, what would our setup be for finding x? X plus 4 equals 12, right? Because that first theorem that we looked at said that these opposite sides are congruent. So x would equal 8. Now, we have these sides that are opposite. We're finding y. We know that these two angles are congruent, so y would just be 65. Not too bad. Right? Right. Okay, good. We have two more theorems to look at with parallelogram. So again, this one should not be a surprise. Theorem 7.5, parallelogram consecutive angles theorem. That these consecutive angles add up to 180 degrees. This Does anyone remember what this is called? I'm drawing in red. You can only see part of it. It starts with a T. Yeah, transversal. And a transversal, I mean, how would we find this angle right here? Or what would it be? Let's start there. It would be, like, what would the letter of it be then? Would it be X or Y? It would be Y. And how do we, sorry, that's hard for you to see. How do we know that? Like, what relationship do they have? Y and Y?
Corresponding.
Yeah, they're corresponding. So, what you'll see come up sometimes, I mean, we look at all these theorems because they're setting it up for us to do some proofs, which we will not get to today. But that's why we have all these theorems, so that we can give a statement, and then in a reason, we can cite one of these theorems. The reason that a lot of these theorems work is because it kind of forms a transversal with a parallelogram. And it shouldn't be a surprise that these consecutive angles, x and y, up here, it should not be a big surprise that these add up to 180 degrees. Because in our transversal, we use that all the time. Those were called what pair? X and y were called, right up here, were called a linear pair. Yeah. So hopefully this theorem is not mind-blowing. Next one. Parallel diagonals theorem. The quadrilateral, this one maybe is not as familiar, but shouldn't be a big surprise. If a quadrilateral is a parallelogram, then its angles bisect each other. So if we have a parallelogram, I said angles, diagonals bisect each other. If we have a parallelogram, and we look at these diagonals, then M here in the middle would be the midpoint of those two diagonals, and at the midpoint, it bisects each side. So that if they tell us that our shape is a parallelogram, then those diagonals bisect each other. On the other hand, if we were to have a converse of this, if I just gave you this up here, would that be enough to say that we have a parallelogram? That the shape is a parallelogram? That would be considered the converse, right? Which is not one of our theorems, but again, what they get into with this is writing proofs. I don't want to spend, we don't have a whole lot of time left in class, so I want to get you the worksheet. There's not a proof on the worksheet, but tomorrow for our warm-up, we might look at writing some proofs using these theorems. The other type of question that you will see with, there's two more types of questions that you will see on the worksheet. I'm going to go through one. The other one, I want you to give a try. Find the coordinates of the intersection of the diagonals of a parallelogram. So we have 1, 2, 3, 4. This is L times L7. 4, 6, 0. We're finding the diagonal, or what are we finding? The midpoint intersection of the diagonal. So we're trying to find this point right here. How would we find that? Midpoint of what? One of the diagonals. So let's say we started with OM, we found the midpoint. Let's see. We take our x's, O is at 0, M is at 7, divide by 2. Take our y's, divide by 2. Now, do we have to find the midpoint of LN as well? No? Could we, though, just to check it? Yeah, if we wanted to check it, we could find the midpoint of LN. And it should be the same as the midpoint of OM. So we're not going to check it, but if you wanted to, I could definitely see on a test or on a quiz wanting to just make sure, because that would be a simple question that you don't want to get wrong, right? You might as well check both. But you would find that the midpoint of LN is 3.5, 2. Also, we can look at our graph, right? We might not be able to draw it exactly perfectly to scale and everything, but if we look at our graph, this is 1, 2, 3.5. Would be here, up to be about here. So at 3.5, 2, with my graph that I just quick sketch, that looks like it's about in the right spot. So we can check it by finding both midpoints. We can check it by taking a look at our graph. Any other questions? Or any questions? In case no one's asking me. Okay. I will get you the worksheet, and then you'll have about 20 minutes to get it done. There is one other type of question on that worksheet, but I want you to try it on your own before